Hi everyone. Today what we are going to do is we're gonna solve a problem, searching an element in a rotated array. So this is an example of the rotated array. We have got 3, 4, 5, 1, 2. So what is a rotated array? For example, we have got a sorted array. Okay, 1, 2, 3, 4, 5. If I rotate this array around 2, then this becomes 3, 4, 5. 1 and 2. So what we need to do is we need to find an element in this array. For example, we want to find 4. So the output should be the index of the 4 in this rotated array. Okay, so one of the simple methods, you go and search for the 4, you will get the index 1. But we want to solve it in minimum time. Okay, minimum time complexity. So what we are gonna do is, we know binary search. Okay, somehow if we can get a sorted array, right, we can perform binary search. Okay, in a sorted array and find the index in log n time. Okay, in log n time we can search an element in a sorted array with the help of binary search. So what this problem looks like, we can break it somehow and search in the sorted part of this array. If you see that this is a sorted array and this is a sorted array in this, right? So if we can somehow search the index of this 5 and search for this part and search in this part whether we have that element or not, okay, so we can return that index. So how we are gonna do? So first step, we are gonna find pivot, okay, or that point before which the array is sorted and after which the array is sorted. Okay, so we are gonna find pivot and then we are gonna do binary search between start and pivot -1, and we are gonna do binary search from pivot +1 to n, right? Okay, meanwhile we'll also check whether the pivot element is x or the element we want, then we can return the pivot value, right? This is what we want, the index. So our problem reduces from finding an element in a rotated array to finding this pivot before and after which the array is sorted. So how we are going to find that pivot? So to find a pivot, if you look at the array 3, 4, 5, 1, 2, see what is the property of this pivot. The number after this is smaller than this, right? Correct? If you see, a pivot is greater a pivot +1. If we check for all the other elements, number after 3 is greater than 3, right? Number after 4 is greater than 5. Number after 1 is greater than only this element. If you see, number after this is what? Smaller than this, right? Only this element has this property. If you check for another property, all the numbers have a property that before 4 number is smaller, before 5 the number is smaller, only before 1 or only after this only this property is true actually. Okay, So what we're gonna do is, let us write an algorithm to find this. So find pivot can be our function where we pass array and some start and some end. Okay, so what we're gonna do is, if start is less than end, then we'll return sorry, if start is greater than end, then we'll return -1, correct? It means that this array doesn't contain the pivot. Okay, we don't have an array actually. If it's an one element array, then we can return start or end anything. Anything can be pivot, anything can be anything. So we can just return start or end anything. So next thing is, okay, we will calculate mid. Okay, mid will be what? Start plus end divided by 2. This is our mid. Okay, so whole thing is based on this. So we get our mid, and now what we are gonna do? 3 4 5 1 2. So if you see, this is our mid. Okay, so if we find out that obviously this should be true, mid should be less than high. Okay, and so next thing which you're gonna check is if mid is less than high and this mid element is greater than mid plus 1. Okay, then we will return mid. Okay, this will be the point, right, after which the next element is smaller. So either if we reach this location or we reach this location, we can return here mid, and we can return here mid -1. This also has a special property that number before it is greater. Everywhere else number before it is smaller. So if we can reach this location also, then we can return mid -1, right? So if mid is less than high, and then this and actually this should be mid should be greater than start. Okay, why I am writing these two statements is, see, I am returning mid thing right here. I am checking for mid plus 1, right? If mid is not less than high, then this can go beyond the index, array index, right? Beyond the array range. So it can throw some error. So I'm checking whether it's less than high or not, so that I can check with a mid plus 1. Similarly here also, it should be greater than start, because I'm going to check with mid -1, right? A mid should be less than a mid -1, right? Then I can return mid -1. Okay, if any of these two cases satisfy, means if mid is this element or this element, we can easily return mid or mid -1 depending upon that. But what if these two cases are not correct? Then what we can do is, next thing is, if the start is less than a mid, then we can do a recursive polish on this find pivot between. Since we know that from start to mid it's sorted, right? So what we need to do is we need to do search on, sorry, I lost this. So I can search on this mid plus 1 to end, and if this is not the case, then I can search in other part of the array, right? I can search in from start to mid minus 1. So once I find the pivot, what I'll do is I'll have okay. So I found the pivot. I'll check whether this element is comparable or equal to X. I'll return the pivot. If not, then I'll do the binary search on this part. Else I'll do the binary search on this part and return the thing. Okay. Thanks a lot.